During our previous presentations, discussions, and video demonstrations, we showcased the powerful capabilities of the SyncLite data consolidation platform. We illustrated how SyncLite excels at performing real-time data consolidation from a myriad of sources, ranging from edge devices and mobile applications to desktop software, IoT devices, message brokers, and traditional database systems. By seamlessly aggregating data from these diverse sources, SyncLite facilitates integration into a diverse array of databases, data warehouses, and data lakes. SyncLite continues to introduce new data integration options, expanding our range to offer over 150 data pipeline options and countless data integration architecture possibilities. SyncLite's data replication and migration solution with a decoupled reader and writer architecture for independent functionality seamlessly adapts to impedance mismatch, orchestrates many-to-many pipelines, and ensures secure data delivery. With diverse replication options, parallelism capabilities, and fine-tuning options, SyncLite caters to complex data integration needs without requiring any configuration changes on the source database. Its broad connector support and statistical reporting further enhance transparency and monitoring, making it the ideal choice for seamless and efficient ETL pipelines. In this demonstration, we'll highlight the database replication capabilities of the SyncLite platform, by showcasing its ability to replicate both data and schema changes from an on-premise Db2 source system, storing TPCH data tables, to a ClickHouse system hosted in the cloud.
We will do a quick table count check of the TPCH tables on source Db2. Note that line item table has over 1 million records, and orders table does not have any records to start with. The destination ClickHouse has a database SyncLite DB created, with no tables at the moment. We will configure the SyncLite consolidator job with most default configurations. We will specify the connection URL and database name for the destination ClickHouse. We will go with default best effort data type mappings. We will set the filter set to block O_ship priority column in orders table, O_order priority column map to O_priority column, and supplier table map to subtable. Value mappings specified for O_order priority column in orders table. We will go with defaults for DB writer configurations, and set ClickHouse engine to replacing merge tree, as that helps in deduplication of record versions created as a result of incremental replication. As we start the consolidator job, the dashboard shows running status with no devices detected at the moment. We will now configure SyncLite DB reader job to read from source Db2 with most configurations set to default values. We will set a default incremental key column, last update time, to enable incremental replication of all tables having this column. On the Configure Tables page, we will enable all tables for publishing except parts of table. We will specify C_address column under mask columns list for customer table, to demonstrate sensitive data masking capability. We will specify a predicate on part table under the select conditions list, to demonstrate selective data replication capability. As we start the DB reader job, the data pipeline is up. We can click on the running status and check the trace messages for the DB reader job. We will go back to consolidator job and monitor the data replication progress. The dashboard shows 7 devices detected and initialized. The devices page shows the progress for all the 7 tables. Clicking on individual device links such as region shows detailed statistics about replication of this table. We can go to Analyze Data tab and execute select queries on destination database. The region table has 5 records replicated. We can do a data check on destination ClickHouse and see that all the 7 tables have been created. Note that the supplier table has been created as subtable as indicated in the filter mapper configuration. We can see that all the 30,000 records for the customer table have been replicated. We can see that the C_address column has been masked as specified in the mask columns configuration in the DB reader. We can see that 20,000 out of 40,000 records have been replicated for part table. Note that all parts with part key greater than 20,000 have been excluded from replication, as specified in select conditions configuration in the DB reader. We can see that all the 1.1 million plus records for line item table have been replicated. We can do a quick data check on source Db2 and destination ClickHouse. No records have been replicated for orders table, as there were 0 records in orders table on source Db2. We will now perform few DML and DDL operations on source Db2 database. We will now import 300,000 records in the order table on source Db2, and demonstrate insert replication. We will wait for consolidator to successfully replicate this insert operation. We can do a data check on orders table on the ClickHouse and see that as specified in filter, mapper rules, the column O_ship priority is not present. Column O_order priority is created as O_priority with values populated as per the value mapping specified. We will update O_comment column for half the orders, that is 150,000 orders. We need to make sure to also update the incremental key column last update time to current timestamp. We will wait for consolidator to successfully replicate this update operation, and then do a data check in destination ClickHouse. On source Db2, we will now add a new column O_comment2 in orders table, and update its value to a substring of O_comment column, for orders with order K 600,000. We will wait for consolidator to successfully replicate this column addition, and then do a data check in destination ClickHouse database, to see that O_comment2 column have been added, and updated appropriately for 150,000 records. On source Db2, we will now drop the column O_ comment, and verify that consolidator replicates this drop column operation. We will now drop the orders table from source Db2, and verify that consolidator successfully replicates it, and do a data check in destination ClickHouse, to see that orders table is dropped. We will now delete around 43,000 records from line item table for line number 7. We will stop the read job in DB Reader and start a delete synchronization job. We can see that the delete synchronization job has finished successfully in DB Reader. We will wait for consolidator to successfully replicate this delete operation, and then do a data check in destination ClickHouse, to see that the records for line number 7 have been deleted successfully, and the records counts on both source Db2 and destination ClickHouse exactly match. The SyncLite consolidator dashboard shows various statistics of the ongoing data replication. You can stop the jobs and start them at any time, and the jobs have a capability to consistently resume from where they stopped. You can create job schedules with the Configure Scheduler functionality, to trigger job starts and stops at specified intervals. This functionality is available in DB Reader as well.
For more information, visit our website, www.synclite.io. Contact us at support@synclite.io. Stay tuned for more updates and demos by subscribing to our YouTube channel. Thank you for watching.